Hello, everybody. Thank you so much for coming here on this last day. I know the majority of you are really tired at this point. No wonder. How is it so far? Did you enjoy the conference?
Yes.
Woo! Really, really happy. I enjoy it myself a lot. It's my first time in the United States, so it's a big, big event for me. Today we'll be speaking about 6 data engineering tips for Tableau developers. We'll be focusing on 2 major things, one of them being the communication, which I find extremely important. If we don't do communication properly, how do we communicate with data engineering team? What do we want from them? And the second thing is the actual tips. What do we communicate? If we, the analysts, don't know what to say, how do we expect that they will actually do it for us? We expect them to read our minds. We expect them to use all their knowledge and figure out what do we want, although they don't know our world. My name is Argo Galowski. I'm a data engineer. I'm an analyst. I'm a director of a small consultancy called DataDune. And I'm also an ambassador as of this year, which I'm extremely proud of. Those are the tools that I'm primarily using in the consultancy. For database, it will be Snowflake, it will be DuckDB, perhaps Redshift. I know AWS is sponsoring this place, so I will not be talking about Redshift too much. Right, for those who are laughing, probably you are also fighting a bit here. Tableau is in the center of everything. dbt is a wrapper. For those of you who do not know dbt, I highly recommend having a look. A lot of the problems we'll be discussing today can be solved with dbt. And for architecture, it will be AWS and Terraform. Now, raise your hand if you ever struggled with the performance of your dashboard. Right, not everybody is raising your hand, which makes me question a lot of things. You don't work with Tableau, or should you replace me here? Come and tell us, how are you not struggling ever with? Because if you're working with any bit of data that is bigger than a couple of hundred rows, you will struggle with it at some point. Is it going to be because you're receiving too many requests? You have 20 filters, you have 100 sheets. It might be then on Tableau side. But more often than not, you will be doing your proper work on Tableau. You know how to do that stuff, but the data that is coming may be slow, maybe too much of it. You might be doing too many transformations on your side. So what are we going to learn today? We're going to learn how to move from this, perhaps to this, 10 seconds, or maybe even 5 seconds or less. And it is possible on the same data. You just have to do a couple of things, perhaps request data engineering team to do it for you. Agenda for today, communication. Again, I cannot stress it enough, this is the core. If you do not communicate properly what you know, this will not be executed. Knowledge that is not being acted upon is a useless knowledge. Data modeling, we'll be briefly, not that briefly, discussing data normalization and what does it mean to you. Indexing and partitioning, how to quickly look through the data and make sure that we have just the right amount of it, not too much, not too little. Optimize the aggregation, everything that you're doing on your side, it should be optimized. You shouldn't be using too many, for example, LODs. We won't be talking especially about this one right now, but about the data engineering part of it and how to move it back to the database. Then data cleansing and platforms. Now, before we'll continue, I have a request from you. All you have to do, guys, is to pretend that we are not talking about data engineering, but we're actually talking about something that's interesting, which will make you smile, and I can make then a selfie. Fantastic. Thank you so much. And let's go into it. Communication. Read this one. I will give you a couple of seconds. Seems pretty clear, right? That's the request that you're receiving. Now read this one. It means the same. It's gibberish. This is one of those requests that you are reading and you're thinking, what do they want from me? I need another coffee. Yeah, it's Monday again, Jesus Christ. Now, this is Pioneer Plague. We sent it into space in 1972. Now, we don't know who will be reading it. We did our very best to figure out, use empathy, try to predict how somebody outside of our planet could be communicating and try to send our message to them. Now, our work is not that different. I know that you're not speaking to aliens. Maybe you are actually, knowing life. Some of your colleagues might be You might perceive them that way. They just don't understand what you're saying. But if you want something from somebody, and that's our job, okay? We are analysts in this context. We want something from the data engineering team. Your data engineering team is probably the bottleneck. You want something from them, so why not to try to speak their language in their way? Whatever it is. It might be a bit different, it might be a bit more technical. You might know this person and know that their communication skill is just different, their style is different. Spend some time, like they did with this Blake, and try to figure out how to write the right request, how to communicate in their way. For example, I need user data accessible in Tableau. Okay, as a data engineer, I'm receiving something like this. If I don't plan to ask you for any extra questions, because, for example, I don't want to do solution making for you. As a data engineer, I might be thinking, you know what? Why cannot you just be clear in your communication? Here we go, all the data in a Bastion in DynamoDB. Well, you didn't specify it. Should I be doing all the work? Remember, you are, as an analyst, requesting something from the other side. It's just enough to put some thought into it, do some decision making, do some solutions, and send it to them. So if you know what you're talking about, and you really don't have to be an expert, just know a couple of basic things. You want GitHub user data. Well, you are receiving this request from your stakeholders, so you should know what data you need. You want it in Snowflake, because you understand that this is the right platform for you to make the dashboard later performant. You know that you want it aggregated monthly. You know that it will be in the future planned for daily usage. All of this is crucial information to the data engineering team. If you provide it, you'll receive it. At least you will have a discussion with them. If you will not provide this information, they might not ask the question. You know the drill. Additionally, you can speak about indexing. You know that you will be using some specific filters. Now, well, they don't know that. They will by default index it by, let's say, date or an ID, whatever it is. You might be using about something totally different. If you know basics about indexing, you might include this information. Usually they will not come back to you because they don't know the usage. This is your product. You are the owner of the dashboard, which means that any backend, you might not know how to do that, but you should request it. And if you don't know what to request, it will not be given to you. The model design, you can also speak about this. You can speak about everything that you know and then use this as a base for your discussion and maybe learn a bit more. Take a step to the left, upstream. So tip number 1, clear, informative, actionable communication. Be clear when you're sending any type of request. Think about it the other way. You also have stakeholders, we all do. You are receiving a request. What if you are receiving an email, make me a dashboard about employees? How many questions do you have from that moment on? You know that there is a whole process. Perhaps you have written down in notes, okay, I have to ask all those questions about the use case, about this, about the filters. People are not thinking about it. What if I told you that we can tell our stakeholders to be clear, informative, and actionable in their requests? Wouldn't your life be easier? Everything will be easier. So don't be that guy. If you're complaining at your stakeholder not doing it properly, well, don't pass the same issues to another side. Okay, second part. Now the technical stuff. What is data modeling and what does it change in Tableau? Let's speak about data normalization. So, how many of you know what's data normalization? Let's start from this point. 1, 2, 3, okay, couple of people, very good, they were talking about it. The normalized data, the normalized table is the very wide one. When you are having too many concepts in one place, where you have 30, 40, 100, 200 columns, and they are just mixing different ideas. Let's say you have orders and invoice numbers and name of the salesperson responsible for it and things like this. There will be a lot of duplicates, and there are a couple of other rules. We don't have to drill down into all of this. Normalized one, think about the normal way, is the one when we hit splitting it into different tables. So you're going to an invoice table. And if you want to bring salespeople into it, you have to make a join. Simple enough. What does it change in Tableau if we're doing normalization? Not speed and not really directly. The problem is here that you might do it the wrong way. So let's go to a simple example. We are having normalized and reduced data size We are taking this big table, we're making a couple of them. That's step number one. Step number two, in Tableau, we are making joins. Now remember that whenever you're doing joins or unions, this is actually computing. You know how it goes if you have too many tables and it's just spinning endlessly. Well, because it has to do all the work. You're doing work on the Tableau side that could be done somewhere else. So instead of doing it there, let's try to materialize it. If you don't know what's materialization, think about just making a table. You can also do a materialized view. There are a couple of methods. Basically, what you're not doing is a view. Because if you do view on the database side, then basically you're saying whenever you're querying it, redo the whole work. You don't want this. You want it to be actually already data on the DB, so we can just query and read it. Example, orders, customers, invoices. That's the normalized one. We are doing normalization. We are exploding it into many tables. Next step, as an analyst, let's just pick some of them. You don't want everything. So now you have less data. We're making it a bit more narrow. And then we're materializing it in the database. So you're querying only this less amount of data instead of the initial one. It's for your use case. It makes sense. You need it to be faster. So why not use Tableau extracts? That could be your question. What if you use Tableau extracts for everything? What if you need it every day? Are you doing daily refreshes? Hourly? Every 15 minutes? At some point, if you need live data, you cannot do it on extracts, right? But if you do too many extracts, then Tableau server will be too busy. Let's say you are a global organization, so you don't have the possibility of doing those extracts only at night. All the time people are using your server. Now, if you will have too many extracts, then the CPU usage will be at 100%, and then you will be struggling loading stuff. And then again, your stuff is slow, and it might not be your fault per se. You only have 10 dashboards, right? Said 100 analysts doing exactly the same thing. That's why we have to learn those techniques. Types of normalization. So you have normal forms. You don't have to know everything about them. It's quite a lot. What you have to know is what is your organization currently using. Because it's not as simple. This is not a progression. This is not to say that the fifth normal form is the form that you should be using. You shouldn't. It's annoying. Just like having no normalization is annoying. Somewhere in the middle is usually the good place where your company will be. But every single level of those has its pros and cons. Now, if you don't know them, that some things might be just annoying you. If you don't know them and you have a problem inside of your system, somebody did the data modeling wrongly, then you cannot communicate it in any way because you don't know what's wrong. Then you're taking it to Tableau and you're trying to fix it there. You're making LODs, you're making all the other ways of removing nulls and the duplicates and things like this. And this is, again, computing, so your performance is suffering. Have a look at the normal forms. Ask your data engineering team. Ask ChatGPT, pros and cons of it. Figure out. Have ownership of your data. Data anomalies. When we're speaking about the normalization, what this is also solving is data anomalies. Now, simple table. If we were trying to add a new department and we still don't have an employee, you have to add nulls. Okay, this is called insert anomaly. What if you are updating? Update anomaly. Let's say that we are changing the name of a department, but remember that this is not just one place. We're having it many times in this table. Okay, you can update everything at the same time, but maybe you forgot to update the system that's actually bringing it, and it keeps bringing the old name. What about deleting? If we delete Monica, don't delete Monica, then you are losing finance. You're losing the whole department. Now what you're doing in Tableau? Scaffolding? You're maintaining an Excel manually in multiple reports? Those are real use cases. You're probably not going to be losing your department because of that. This is too simple of an example, but you are deleting sometimes things, and then you're having issues if you don't do the normalization. So let's do simple normalization. We simply take the department out and we're replacing it with an ID. Now again, the problems that we had before. You're trying to insert a new department. Well, you're just inserting it one row in the department table. What about updating it? You update only one value. What about deleting it? Well, even if you delete an employee, you didn't delete the department itself. That's one of the reasons that we're doing the annoying stuff. I remember when I was a junior analyst, I thought about it, this is just annoying. Why are they doing to me? Why can't I just get one table and read everything? I have to understand the IDs, primary keys, I have to do all the joining. That's one of the reasons. I can fix it in Tableau, right? Again, like I said before, yes, you can do almost everything in Tableau. It's a marvelous tool, but if you're doing too many things, then the performance is slowing down. And I know that you noticed it at your work. You probably easily can spot when you have 100 sheets on one dashboard that things are slow. All right, you can fix it. But this is the way to fix the data coming in. When you're doing normalization, you should expect to have the lineage and the documentation. Just like when I was a junior and I didn't know how to do all those things, I have to reverse engineer almost all those tables. We shouldn't be doing it ever. It doesn't matter are you a junior or a senior, it's annoying. Documentation and lineage should be there. We should request it from the people who did it. Those are data engineers. We have to communicate to them and stress it out. We know that you are busy. We know that there are only 5 of you and there are 100 of us and we are keep bugging you about things, but you have to keep updating the lineage, you keep documentation. dbt can actually help you in this because dbt has something called the Explorer right now, and automatically lineage will be updated there. So you can go, you can reference it, you can see the data is coming upstream from those places. Perhaps already a table that you are looking for is existing. Why are you querying the one that has too much data? Why are you trying to do all the things we just discussed? Perhaps your colleague already did it a year ago, but you don't know about it. Because how can you know everything if you don't see lineage documentation? In a big organization, it's just impossible. So why is it important to me? Think about time and effort. Think about either doing the ad hoc dashboard, and this is fine that you are not thinking about data engineering in this point, because it's just too much work. You have to balance it out. What we're discussing here takes time. Maybe you can do it on your own, it's fine. If you know how to do those things, or at least some of them, you will know how difficult it can be. Even going through the request, through the PR, through the approval, it can be difficult. On the other hand, you have the data product. For those of you who don't know what are data products, check out what's data mesh. It's about ownership. If you own something, it means that you want to do it properly. You want your colleagues to not go through the same work, the same footwork that you've been doing. And then all of this is worth it because you're creating something from A to Z. Reusable. Yes, it's more work right now, and yes, you have a lot of pressure to deliver it by Monday, but how about we'll actually stop adding tech debt, pay it right now, pay our dues, do it properly. In the future, it will pay off for you and for your colleagues. And additionally, when you're trying to, for example, edit relationships, when you're doing cardinality, when you're doing the referential integrity, do you know what are those things? Do you really understand what you're doing? Because you can actually remove a piece of your data and you won't even notice it. You can actually make the performance slower in some cases. Maybe things will change and you didn't update this one. Now, if you don't understand at all data modeling, then you might run into different issues. So consider the following. Do I use all the columns? We're trying to make it a bit more narrow. And can I make less joins and unions? Because again, this is the materialization part. This is the part where you're taking a couple of pieces. Hey, I would like to move this back to the database. Do I experience anomalies? Now you understand what are anomalies. Yes, you can exclude nodes in Tableau. But if you have millions and millions of rows, this is just additional thing that Tableau is doing. And don't think that this is easy. Tableau server can do a lot of things, but remember, going through millions of rows and doing transformation to it, excluding, including before even trying to make a visualization, why not to do it properly in the other place? And if you did it, will your colleagues know about it? If they will be using the same data, let's say GitHub users, will they come to you and start asking all the questions? Will you know how to answer them? Or will they start taking the same steps like you did, perhaps missing something, perhaps doing it differently, then you're working on the same data and you have different outcome. Why? Because you haven't centralized this transformation. So is the data structure and schema understandable? We're doing all of this, document it. Indexing, next topic. let's do in Tableau and look for one employee. On the SQL side, this is the query that's being sent back to the database, is just select everything when employee is named Toby. All right, so what is actually happening? We're doing a full table scan. The table is not being indexed properly, so we're having the ID, we're having the employee. Now try to look for Toby on the employee. It's not that difficult, right? Because it's alphabetically ordered. Now let's look for ID number 6 on the second one. It might be even easier, right? Because it's not only alphabetical, but also it's easier to spot the numbers. So we have 2 points here. One of them is the order. It's easier for the database to look when something is ordered by it. And 2, it's easier to look at it when the data type is correct. So looking, for example, through digits, couple of them, is easier than looking through a URL that has 200 plus characters. That's pretty simple, right? Well, if it's pretty simple, and we'll go back to it, then why aren't you making filters that are simple? Now, data blocks. This can be a bit confusing. This is how, on the database side, this is working. Instead of having those lists, like we can see on the left side, when we're indexing it, it goes into blocks and indexes. Think about an array. Inside of each of those, it's a grid. You have an array. This array is just the row of data. So you have everything from the row about Adam in 0, 0. Block 0, index 0. This is being done because when we're doing the indexing, we're having a hidden table, let's call it for simplicity that way, and when we are ordering it by Toby, we're filtering it from Tableau. We're sending it to the database, it looks through an alphabetical list of Toby, then it has, let's call it mapping, block 2, index 1. It can retrieve it easily. Additionally, this is already an improvement because of the indexing. Additionally, we have something called B-tree, the binary tree, and this works as follows. Let's focus at the beginning on the numbers. It always goes left is the smaller, right is the bigger. We're looking for number 1. Is 1 bigger or smaller than 4? We're going towards the smaller. We're going towards the smaller all the time until we find it. Each time, we are excluding 50% of the existing data, which means that we're having a huge improvement in performance. How big? Time complexity. The blue line is the linear one. It means that whenever you're adding extra data, it will be taking extra additional, the same amount of time to look through it. Think about me giving you a list of 100 names and then adding another 100. If you have to look through everything each time, it's double the time. Makes sense, right? Well, if you're using it on the database side, then you're looking at the red line, the logarithmic one. Now when you're adding way more data, you're actually only slightly increasing the amount of speed. But as you see on the graph, it works for a lot of data. The more data you have, the more beneficial it will be to you to look into the indexing. So, to boil it down, use most common filters as index, and think what filters you're using. If you can, instead of using a filter on a URL, use a filter on an ID of an employee. Perhaps it's enough, if this is the most popular one. And now, since how many of you have been yesterday on the talk about new features? How many of you have heard that we'll be having an easier way to figure out what are our users using? Now, this is the way, right? Now you know that a specific filter is being used all the time, the rest of them not at all. Or perhaps remove the rest of the filters, and the filter that they are using, that's your indexing. Perhaps we can also simplify it. And select high cardinality, which means a lot of uniqueness. Don't select in a, for example, country field, because then you have a lot of repetitions. Select something like ID. That will be the best, that will be the easiest way. And this will improve your performance exponentially or logarithmically. Now, why are we talking about this? Because your team, your data engineering team doesn't understand your dashboards. Do you think your data engineering team is coming to your dashboards and trying to analyze it, what you're doing, and then they will come to you and say, oh my God, I saw that you're using this filter. I have too much time on my hands. let me add you. I will come during the weekend and try to reindex stuff. Let's have a call. Happens never. We are the owners, right? We have the stakeholders. We are responsible for dashboards that are performant to those people, which means that we have to take a step back and ask data engineers in a way that they can understand what's supposed to be done. So the answer is to index it all. Now, Igor says, index stuff, index it all, problem solved. Yes, but we are creating this invisible extra table, right? There's also possibly some maintenance in the background. When you have some platforms, you have to do something called reindexing once in a while because you have too many, it just becomes problematic. You cannot index everything. You have to be smart about it. And this is why you have to analyze your dashboards, what you're doing with it, and perhaps test it. Yesterday, after one of the sessions, I had a question, what to do if I don't know which field to use for indexing. I don't have the access to production. I'm not a data engineer. I'm like, fair enough. Do you have access to the development? Yes. Well, if you have access to development, which you should as an analyst, you can test this stuff. It's quite simple to index. Just hook it up, load a lot of data, dummy set, and try to figure it out. Then you will understand more. Get interested in it. Don't leave everything to the data engineering team. It's actually fun. Partitioning. So we know right now that we would like to have less columns. Not too complicated. How about also having a bit less data on its own? Let's say that with products, you are working only with the consulting. Now, why are you having a data set of 15 million rows with both consulting and subscriptions when you're only working with one? You're all the time loading everything into Tableau. How about we create two different tables? That's basically partitioning. Go to your team and ask, we actually need them separately. I want this piece, this small piece. Again, this is not going on its own to move your dashboard from 60 seconds to 5. That's not what it is about. It's about incremental change, many small changes that together add up. Split the data if you have too many rows. Maybe by product. How about by something called tiering? This is by the time. So, you're having a dashboard for the C-level that's only about the last 30 days. You're not making a comparison to the past. All right. Make a table called hot. This is last 31 days. Usually, you can do it however you want. Warm would be last 12 months. Then you have cold as 5 years, then previous 5 years, and then you just purge stuff. You don't need commits made 15 years ago by an employee that already changed 3 times his industry. You don't have to load all of this. You can keep those tables separately. And then again, you are removing a lot of stress from Tableau itself. So what do we communicate to the devs? Select the right indexing, because you should know what is happening on Tableau side. And use smaller subsets. As simple as that. Just use less data. Optimize aggregation. Which one would you prefer to work with? The 15 million or the 7 rows? 15 million. Perfect. We like big data, right? The thing is that if you know that you will be working only on some specific aggregation with it, why not to do it in the database? Do a lot of things on the DB. If you're struggling with performance, do the transformation itself. Tableau is great. Tableau can do everything. It's not an ETL tool in the end of the day, right? And I know that a lot of stakeholders are treating it as such. Can you please do all those transformations and business logic? Please skip documentation. We never care about it. It has to be deployed tomorrow. And then I would like to download the table. Well, this stuff should be done in a database. Even for the documentation and business logic. If you are doing some business logic in Tableau, if you're doing too much of it, and then you have to replicate it somewhere else, there is a chance it will be different, maybe outdated. And then we're struggling. Then we're having those stakeholders coming and saying, look, those 2 dashboards, they are not really aligning. Well, no wonder. We're literally using different logic for it. So, raise your hand. Who knows what's profiling? Data profiling. 2, 3, 4, 5. All right, let's talk about profiling. We should be doing it. You probably know those screens, at least one of them. You should know the one on the right with Tableau Prep. Probably you've seen it before. This is one of the ways to do data profiling. The left one is a screen you will see in, for example, DuckDB. You will see it in Snowflake. Similar screen to Tableau prep would be in Databricks. Basically, it has a look in a holistic way on the data set. You can easily say things like the amount of unique values or the amount of nulls. Probably you don't want to have a data set with too many nulls. Possibly you don't want to do too much transformation working with duplicates in Tableau. You're doing data profiling and you quickly understand the data. It's not a waste of time. It's not a waste of time because you might discover in 10-15 minutes that you don't want to work with this data at all right now, and actually you have to go back to the data engineering team and ask them to do their work properly. Because if data is really messy, you shouldn't be doing this stuff. Maybe in your company you should, but then how are you doing it? Are you going to Tableau and you start dropping all the fields and spending an hour trying to figure out what's where and then counts? And how about just using a tool like this? You don't have to be a developer to do this stuff. Let's say you don't have Tableau prep, you don't have Databricks, you don't have Snowflake, no idea how to do it. To do it in DuckDB, which is for free, it's literally a couple of commands. Just copy paste it to the terminal and it's running. Issues that you can find, very common ones in profiling. For example, you're having two different emails. One of them is null. You should do coalesce in the database. You shouldn't be doing this inside of Tableau. If you do it in Tableau because you have to, fair enough, and then you do it in the second workbook and your colleagues are also doing it, and you're just wasting computation. Number two, what if you have just nulls? Okay, again, you can just exclude it, or you can do it in database. Or you have duplicates for some reason. All of those things are just messing out the data. Clean data is just easy to work, and I know once in a while, once a year, when Christmas comes and you receive a nice data set that is actually clean and easy to work, isn't it just gorgeous? Now, probably majority of data sets are not like this for you, but going back to the data mesh idea, if you do it, if you push the data engineering team, then maybe at least your colleague will have a Christmas. So aggregate it in database and simplify and transform it. Push it back. You probably all know SQL. You could just go and do some of those transformations. Right now with all this Copilot and ChatGPT, etc., you can write this SQL in no time. At least you can propose something. And now you know what you're supposed to be doing. And finally, we're going into the platform. So we have the transactional and the analytical parts. For those of you who don't know, you might be often requested to do it the wrong way. Now, if you're being requested to work on the transactional side is meant to be quick for inserting, updating, and deleting. Think about, for example, a cash register. You have a lot of transactions coming in very quickly. You need the transactional part of it. But the analytical part, the data warehouse, this is for reading. Now, if you're doing it on the wrong side with too much data, it's just slower. I know that you don't usually have anything to say about the platform. It's already there. We've been always doing it that way. Well, yeah, but if you understand this stuff and you communicate it, perhaps with time, change will come. It will be somewhere there in the backlog of, we should do the migration. It's been too long, we have too much data. And it will just happen, you never know. So you want to work with Redshift, you want, Snowflake and DuckDB. You don't want to work with MySQL and Postgres when it comes to Tableau. It's just slower. And finally, let's speak about the documentation. Again, I cannot stress it out enough. You should request documentation. You shouldn't be reverse engineering everything. Lineage should be there. If you have complicated or even uncomplicated data model, it should be there because simply it says what and where and how. For example, let's say that in Tableau something is not working. You notice that users are not coming in. All right, where are users coming from? Now you're reading the table, you have absolutely no idea where this thing is coming from. It might be upstream 10 tables. It might be going through staging, through transformation. What are you doing right now? You're going to GitHub and you start reading the code? Hopefully you're using GitHub, Jesus. What about if somebody's just dumping code? All right, now you have to read all of those, one after another, where from it's coming, until you're finally discovering what is the problem. It's coming from some API. Then you're looking for a person who's responsible for all this stuff. Where did I find his email? All right, He's already gone. That's Lineage, and that's data mesh with a simple contract that says the ownership of this belongs to XYZ. Entity relationship diagram. Back to the normalization. How do you make joins and unions? Joins. Primary key. What is it? Maybe it's not that obvious. Maybe it's not written down. You don't have to discover this stuff. You should just read it from the diagram and know immediately what to do. And finally, documentation. For example, why are we doing something that way? You're missing a proper ID, or you're missing a URL for something. Why is that so? Because perhaps it's not possible to get it, perhaps it was very time-consuming. There is some kind of reasoning. Again, the person that might be responsible for it is gone, or you don't even know who. It should be written down in an easy way. If you have documentation, if you have the lineage, on one glance, in a couple of minutes, you can understand the whole thing and what to do. So document it all. Also, you guys document it in Tableau for yourself and for others. And monitor the performance. This is the final one. Now, how many of you, raise your hand, how many of you know for sure that all your dashboards are performant? One person. Nice. We're going to talk after the presentation. People just don't know, is it performant or not? What we are doing, we are counting that our users are going to come and complain about it. But if you were a user and a dashboard will be working, let's say, slowish, a bit sluggish, 8 seconds, it's up and downs, you don't really understand why. Maybe it's the server, you're thinking, they're gonna give me some excuses again. You might not communicate it. And if we don't know about this, then we don't know we should do any work. We don't know that we should improve the performance. If we're not improving the performance, then it means that the engagement might be low. And then you are sitting and thinking there, stakeholders. They were requesting all this dashboard, nobody is using it. I wonder why. If only I knew. Easy way to do it, pretend you are a user, once in a while. It would be great to have monitoring in place. It would be great to query the Postgres, or right now we're gonna have the new feature. But you still have to look at it, right? Even if you build a dashboard and you will understand the usage and the speed of it, you still have to look at it. Make yourself a calendar reminder every 3 months. 30, 45 minutes, I'm pretending I'm a user. I'm going around, I'm clicking through the use cases. I have those use cases written down. They wanted to do 1, 2, 3, 4 on this dashboard. Let me pretend for 5 minutes I'm one of them. I wonder, is it usable? I wonder, is it performant? And then you have your actionable list in the backlog. Okay, actually, I did it back days. I think I could do it better right now. Let me request a bit of time. One day, I will try to improve it. Oh, this is working really slow. I wonder, let me measure the performance. I wonder, is it the query or maybe my dashboard? Maybe something has changed on the server itself. You never know. Be a user. So the takeaways. Proactive communication. Know what you're communicating. Be the nice person. Be the person that you would like to have as a stakeholder. Normalization is your friend. It's not your enemy. You don't want to work with those large tables. What you want to do is to have as little as possible and also less data. So partitioning. Indexing. This is your filters. Remember, use smart filters if you can. I know sometimes you cannot. And try to index the popular one. Figure out which ones are they actually using. Aggregation. If you're doing a lot of this on Tableau, it will be slower. Move it back to the database. Computation to the B. And right platform. Try to use the correct platform if you can. Request it. Ask them to move the data from the transactional one into the warehouse. And the documentation. Thank you so much. Coffee on us. Scan the code. Probably you already seen it 100 times until now. If you want to chat about those things, please hit me up on LinkedIn. I'm always happy to chat with people. And have a lovely day. Thank you so much for coming to the conference, guys.